Okay, let's get started. This is section 3.4, the slope of a line. Before you copy down these formulas, I would like you to look at the cases that are possible. We can have lines that have positive slope. As we read a line from left to right, if the line is going upward, it's like running uphill, it's positive slope. Notice that the blue line is steeper than the red line, and the purple line is the steepest of all. So not only do we need to know that this has positive slope, but we need to be able to measure how steep the line is. That's what this formula is going to do for us. Then we have negative slope. As you read these lines from the left to the right, they go down. They're decreasing. It's like running downhill. This is the flattest slope, steeper downhill. The steepest downhill are the ones that I drew 3 examples. They don't have to go through the origin. I just happen to draw mine through the origin. So this is negative slope. If from left to right, the line is going down, it has negative slope. These lines are flat. This is like running on a flat surface, and it has 0 slope. And that's a horizontal line. We talked about those previously, and you know what the equation of that will look like. And these have undefined slope. These are the vertical lines, and it doesn't make any sense to measure the slope. They're absolutely straight up and down, right? So that is undefined slope, and mathematically that's when we get 0 in the denominator. Okay, to calculate the slope, we do the rise over the run. We measure the change in the y divided by the change in the x. It's a ratio. Or we subtract the y values over the difference of the x values. And finally, I like to think of it as the vertical change over the horizontal change. All right, so that's what we're dealing with. Again, if this is going quickly, you can pause it and back up and replay anything that's necessary. Okay, let's begin with the first example. Example 1A. They're giving us 2 points, 1, 5, and 6, 11. And we are to calculate the slope. So on this particular problem, I will label this first point with the x, y, and I'll put a little subscript 1 because I want it to be clear that it's 1 point, it's the first point, and it doesn't matter which one is the first and second. This one that's listed second, I will call the second and call that x subscript 2, x2, y2, that's what they say. So to calculate the slope, we're going to use these points and use the formula y2 minus y1 over x2 minus x1. So I'm the change in y divided by the change in x. So I go to y2, y2 is 11, minus y1, which is 5, all over x2, which is 6, minus x1, which is 1. And that gives me, I can go over here, that gives me 6 over 5. So this has a positive slope. It's going up at the rate of 6 vertical units for every 5 horizontal units. That's the slope of this particular line. Okay, let's do the second example now. One B. They would like us to work with the points 3, 6, and -2, 9. And because I want a particular thing to happen, I'm going to call this point my x1, y1. It doesn't matter. 1 point is your first point, and this is going to be my x2, y2. All right, so I use my formula y2 minus y1, subtract the y's, over x2 minus x1, subtract the x's. Notice that they have to both start with 2 or both start with 1. They have to be lined up here. All right, so we take the y2, which is the 6, minus the y1, which is 9. And again, I'll show you why I'm doing this now. x2 is 3, minus, I wanted to have to minus the negative. That's the reason I did these backwards this time. So I'm minusing the x1, so I'm minusing a -2. So I have a -3 over, this is a 3 plus a 2, -3 over 5. Okay, so the slope of this line is -3/5. It's downward sloping 3 vertical units for every 5 horizontal units. Okay, part C. And this has the points 3, -1, and 4, -5. And usually the first one that's listed you call x1, y1. You don't have to. x2, y2 for the second point. And I'm going to go directly into my slope formula this time. We take y2, which is -5, minus the y1, minus a -1. And you're welcome to skip that step and just write it as a positive. That's fine. Be careful though. x2 is 4 minus x1 is 3. So I have -5 plus 1 over 4 minus 3 is 1. So I have a -4 over 1. Looks good. Okay, so if you're given 2 points, which you will have one test question, you can just predict you'll have one of every type. You'll have one test question where you're given 2 points and you have to calculate the slope. Okay, let's go to number 2. And this says to find the slope and the y-intercept of each line. So the first thing we need to talk about is the slope-intercept form for a linear equation. Okay, and this is what it looks like. And I know you've seen this before, y equals mx plus b. And how this works is if you solve an equation, a linear equation, and remember those are equations that have x to the first and y to the first. Those are the linear equations. If you solve it for y, put the x first, this value will be the intercept. So this tells us the slope, m is the slope. Whatever number is sitting in front of that x will be the slope. And this value at the end will be a numeric value, and it will tell you the y-intercept. So this could be called the slope y-intercept form for an equation because those are the two things that you are given. Now, in these problems, we're just going to be writing things in this form and identifying the slope and the intercept. So that won't be too hard. There are other forms of the line that we'll be learning in a little bit. 2a. Y is equal to x plus 3. Okay. Remember that this, when it's written like this, y equals something x plus something, then we automatically know that the number in front of the x is the slope. What is the slope in this problem? Nothing's written there. No, it's not a 0, right? If there was a 0, there would be no x, right? There is an invisible 1. We have 1x here. So the slope of this line is 1. It's rising and running at the equal rate, 1 to 1. And this value right there is the y-intercept. And they're only asking us to find those two things. They're not asking us to graph it. But if we were going to graph it, this would be the point. Remember at the y-intercept that x is 0 and the y-intercept is 3. So this graph goes through the point 0, 3. So if I wanted to graph it, one thing I know is that it goes through the point, the y-intercept is here. On the y-axis, it intercepts at 3. Okay, and we'll be doing that later, but now we're just working with the equation. Okay, number 2b, y equals -4x minus 1. Identify the slope and the intercept. Okay, we know that the slope is the number that sits in front of the x, so it's a -4, right, because this is in the form mx plus b, and that the y-intercept will equal this number right here, right? -1. Don't forget the negative. That's an intercept. My handwriting was messy. Okay. Let's go to 2c. And 2c is -3x x plus y equals 9. Sorry for that strange looking y. Okay, if we want to identify the slope and the intercept, as we're told to do, let's get it in the form like this, mx plus b. So we want to leave the y over here. We're going to add 3x on both sides. Notice we always put the x first and then the number last. So we write it like this. So I solved it for y, putting it in the form x and then constant. And so in this particular problem, remember the m sits in front of the x. The slope is 3. And the y-intercept equals 9, positive 9, because it's that value right there. So the only thing you have to remember is to get this in the form y equals mx plus b, and then you can peel those numbers right off. Let's go to part D, and I need to get a little paper here. There we go. 2D, x equals 3.4. Again, we want it to be in this form, y equals mx plus b. There isn't a y here, so that's what's kind of confusing. But we want the x and the number to be on this side like that. So we're going to leave a 0 over here. What does this graph look like? Let's think about that a second. X is 3.4. So right over here, x equals 3.4. X is always equal to 3.4. So let's just think about this one. This is one we need to think about, okay? It's a special case. What is the slope of a vertical line? Do you remember at the very beginning of class we drew those cases out? Let me see if I can put my hands on those. No. The vertical line had the slope undefined, right? Here we go. Vertical lines have undefined slope. So this has slope undefined, and does it have a y-intercept? Does it cross the y-axis? No. So we say no y-intercept. It has an x-intercept but not a y-intercept. Okay, let's look at E now. So that's a special case. When you get something that doesn't have a y in it, you're best to just think about the graph of it and work it from there. It doesn't really fit into this form y equals mx plus b because there is no y. Okay, that was D, and now let's look at E. Y equals negative 1/3 x. Okay, now if we can get it in the form y equals mx plus b, then we can identify the slope and the intercept. It is in that form, right? This would be the slope, negative 1/3. And what would be the y-intercept? That would be the part that's added at the end. There isn't anything. So the y-intercept is at 0. Okay. We don't say that it has no y-intercept. It's like there's an invisible plus 0 here, right? Its y-intercept is at 0. Okay, and I think they may be writing these as points. Let me look at the answers down at the bottom and see. Oh, it looks like they are writing these as points. So the y-intercept is at the point 0, 0. So perhaps we should have been writing all these intercepts as points. We'll do the next one that way. Okay, let's do F. And 2F says The line is 2x minus 9y equals to 36. And again, we must solve this for y if we want to be able to get it in the slope-intercept form. So I leave the negative 9y over here, and I subtract 2x on both sides. Show the steps if you need to. Now I'm going to divide everything by negative 9. So I'll have a negative 2 over negative 9x and a 36 over a negative 9. Feel free to skip those steps and if you need or want. That would be a negative 4. Okay, so on this one, the slope is 2/9. Remember, it sits in front of the x. And the y-intercept is negative 4. So we're going to write that as 0, negative 4. And this is how they wanted us to be writing them, I think. So we'll start now doing that. You can go back and switch the others if you'd like. The intercept's at negative 4. And remember, at the y-intercept, x is 0. So you just simply write it as a point in xy. X is always 0 at the intercept, and the y is negative 4. Good. And finally, we have g of this type example, 2g, and it has y minus 8 equals 0. And so we write this as y is equal to positive 8. I added 8 on both sides. This is a special case, okay, and I like to think of the graphs. Y equals 8 everywhere. So we go up here 8 units, right? This is at 8. Y is equal to 8 everywhere. So this is a horizontal line when it says y equals, and that was on the special cases that we did at the very beginning. You can flip back in your notes. And this has slope 0, right? And if you notice, this can be thought of in the form y equals mx plus b. This is the b, and we don't have any x's. So in this case, we have 0 x's, so the slope is 0. But again, I think you're safest to graph these and think about them. And the y-intercept will be the point 0, comma, the y is 8, right, because that's the b. And the intercept, you can see it intercepts the y-axis here at 8. Okay? Good. Okay, I'm going to stop and take a break and continue this in a second part.